I think we'll get going. So thank you very much for joining. Welcome to my December edition of the webcast. As usual, I'll talk about news first, then show you some technology things, rules and stuff, then move over to log file analysis, and then show you new stuff around the CRegEx helper tool, around false positive, and then the false positive analysis script that I'm currently developing that is being consolidated now, and I'm soon have a production ready version. So news, CRS still doesn't have a release date for CRS 4. Why is that? Because we still struggle to get the bug bounty findings from early this year sorted out. So we had quite a lot of bug bounty findings reported during a big campaign in April, May, and we fixed hundreds of individual attack requests. We had over 100 reports, and that resulted in hundreds of potential attack requests. So things we would not detect. Most of them are fixed, but we're really struggling to fix everything. Let me show you just how much that really is. Changing my screen now. Bug bounty, no. Where are my bug bounties? Bug bounty tests. Results, no. Bin, get stats, results. And this was the situation at the end of, this was the situation with the bug bounty findings at the end of November. And it improved since that, but not completely. So we have like 480 tests. That is stuff that was not detected in spring. At paranoia level 1, at the end of November, we would detect 362 of those. So 75% were detected by default, and 22% were not detected at all at paranoia level 1. Then at paranoia level 2, we're up to 90%, and paranoia level 3 up to 91%, and then paranoia level 4 we're up to 97%. Now, ideally, we would be at 100% at paranoia level 1. However, this cannot really be achieved because there are some of these attack requests that are so close to the English natural language, it will be very error prone. So we're rather aiming to detect everything at paranoia level 2 or at least paranoia level 3. But there are also a handful of findings where we will have to conclude, look, we're not able to use this as an exploit. I mean, it looks aggressive, but we cannot possibly see how an application should fall victim to this. So this was reported in the bug bounty. It was a lot of findings, a lot of stuff was accepted, but now on closer inspection, we think, look, it's very hard to detect, and a handful of these are not really real exploit. It just looks dangerous, but it's not a weakness that we have to expect on the backend application. So we're aiming for 100% here at paranoia level 2 or 3. We're still not there despite month of work, but you also see we've covered over 430 cases, and it's been a lot of work, and the project has been struggling. Now, before I started with the webcast, I've been talking to Edgar's about the real news that hit the ModSecurity or the WAF world last week. There was Black Hat Europe in London, and a company called Clarity, a research or security research company, presented new findings. I'll show you the, here is the blog post from Clarity, where they have developed a new technique using JSON to bypass SQL protection web application firewall. What they aimed for are commercial web application firewalls. I'm scrolling down here. I think somewhere they have the names, all of the products affected. Here they are. So Imperva, AWS, that is easy, F5, but also Cloudflare and Palo Alto. The only one that we're really sure they're based on core rule set on CRS is Cloudflare. However, we also know that Cloudflare is only running a relative, well, let's not call it small. Let's just say Cloudflare uses a subset of CRS. And the other ones are probably not really use CRS. AWS tells us, look, it's not really CRS what we're doing. F5, not, at least not in the standard web application firewall. And Imperva, pretty sure. And Palo Alto, I just don't know what they're using. So Clarity, the guy that presented this, have shown that these 5 commercial products fell victim or were not able to detect this new attack technique. We jumped to action immediately as a CRS team, and Andrea Menin from Italy dug down into this over the weekend, and he came to a conclusion that CRS detects most of it by default in paranoia level 1, and everything is detected at paranoia level 2. This assessment was also confirmed by several of our sponsors that this test themselves, and they asked us what our reporting was on the subject, and we said, look, we think we got everything covered in paranoia level 2, and they would confirm that. So that looks pretty good. However, Andrea was not satisfied with this, and he would continue work to make sure that we're protecting what is 100% by default. So he wanted to have a rule that really detects this in the default installation at paranoia level 1. And that rule was merged last night. I'm going to Twitter, core rule set, because there is the link. So core rule set on Twitter is our team account. And here is the link to his pull request. There was a very long discussion for several team members, talked about this, and then Imperva, one of the affected company, would follow up with an additional blog post where they posted more stuff, so more attack payloads, and they all were transformed into unit tests for CRS to test the new rule. I'm going to show you the new rule that Andrea developed. It's this rule here. As usual, very hard regular expression, very hard to read. And in fact, this is now based on a new regex assembly tooling. So these are the payloads that we define in a data file, in a special crafted format that's all fairly well documented. And then the regex assemble script will use this and create this new regular expression. So this is a machine optimized version of the various snippets up here. We have been doing this for years, but not as sophisticated as this, because the interesting thing is now that we have defined statements where we can define quotes. So these are the quote characters. Here are the various operators. This is a JSON ending bracket, and we can then reuse that in the assemble step where we assemble the various snippets into the regular expression. And here is even a comment that explains the final string. So this is new tooling. It's much more sophisticated. This was developed during autumn, but namely during the developer summit in Italy at the end of October, early November. And here Andrea makes use of this. He worked for 1 or 2 days on this pull request on these new rules. They were merged last night. And if I scroll further down, here you have the unit tests, all the stuff that the Clarity guys published in their blog post and their presentation at Black Hat, and then additional payloads presented by Imperva. Andrea is now preparing a blog post about this to explain what he has been doing exactly and how you can use this rule immediately. I mean, you don't have to wait for CRS 4 where this is integrated. You can, in fact, take this rule and use it in your installation immediately. One word of caution, though. CRS is an anomaly scoring rule set, and the name of the scoring variable down here, the inbound anomaly score PL1, has changed. In CRS 334, so the stable release, the variable is called anomaly score PL1. The inbound underscore prefix is not there. So if you copy this rule into your existing installation of CRS 3, you will have to rename this variable. But if you do this, it's good to try this out anyway. Take one of the unit tests, copy this into a curl statement, and try out whether the rule triggers and whether you're blocked or not. So it's easy to find out. But Andrea will explain this in a blog post, I guess, coming days on corralset.org. So that much on the news. This is what's going on. It's been a very busy week. You might remember a year ago, we had the log4j weakness, which is all over the place. This year, almost the same date, we have a new JSON WAF bypass technique. It's not as bad as log4j, but still busy days for WAF developers. Good. I'm now going back to the console, and we're looking at the log files, as we usually do here in the webcast. So as usual, we're looking at production logs from netnea.com. So netnea.com is the website that you probably know. This is where I publish my tutorials. This is where you can learn to run ModSecurity and the Coral says. This is also where I announce courses and dates. Next public on-site course, by the way, is going to be in March 23 in Zurich, hosted together with Switch, a Swiss internet company or foundation. But good. So log files. The standard log report I'm always showing, this is the summary of what has happened since the mid of November, since last webcast. We had 430,000 requests. 13,000 of these requests had alerts. That's 3% of the requests. So 97% of the requests went without an alert. I think the number of alerts is traditionally quite high on netnea.com. That is because it's a fairly popular site. It's situated around security, maybe that attracts attackers. But what is the most important is probably it's clearly a WordPress website. And it seems that WordPress is constantly being attacked, namely here. I'm running other websites as well, a bit less traffic, but far, far less attackers on them. Of these 13,000 attacking requests, we blocked almost all of them immediately. 14 went unblocked. These are 14 that did not meet the enemy threshold. And one of these 14 actually was a relevant request. I'm not repeating what is relevant or not, but let's say most of the attacking requests are actually relevant here. As it happens on other production side, namely with my customers, they have less relevant requests. I think that is also specialty. I don't really understand why. If we scroll down, we're seeing standard as usual. We have 87% of GET requests, relatively few POST requests, because it's not very busy being edited. And then we have 500s. Let's look at those. I think that is interesting because netnea usually doesn't have any 500s. So let's go. I quote the double quotes. All right. I do use the double quotes. This has to be escaped. and then status 500 space in the access log. The obfuscated access logs, you don't see the original IP addresses. The double quote makes sure I'm really getting the status code, because the status code is immediately after the request line in the access log. So let's get this. So these are these 5 requests. It's a post request to WP includes 5 times actually. It's always the same request. It's seems to be mostly different IP addresses from different countries. I can go IL country, yeah, 2 times Croatia, same IP address, and then US, Netherlands, and Great Britain. I can already tell you that this is a non-existing address or a URI. Nenea is running under /CMS, and we don't have WP includes. The path does not exist. But why did we get a 500? Let's grab with the unique ID on the error log. And it seems they posted an XML document that could not be parsed. So there is a rare situation where ModSecurity is not able to parse something, but instead of returning a bad request, a status code of 400, ModSecurity actually gets a hiccup and it returns a 500. The situation is relatively rare, but it really happens in production. So you can craft an XML document in a way ModSecurity blows up. I think it isn't dangerous. I've never seen a real security problem around this, but it's not nice. I mean, ModSecurity should not throw a 500, but at least we see it's an XML parser error. It failed to parse the XML. Okay, so that is settled. We know what that is. And then scrolling further down, IO is always the same. IO in is usually very small. IO out is 7 and 38, so median and the mean, the average. Performance is okay. CAPEC, we usually have protocol manipulations, a lot of them. So this is all very standard. What else do we have here? Yes, the illegal header except charset. I think I've touched on this last week already. I'm a bit puzzled because of the rule ID. I thought it was a different rule ID, but whatever. So the illegal header except charset on relevant requests is really the biggest item that we're seeing. Why is that? What is except charset anyway? Except charset is a legacy HTTP header that is deprecated. It should not be used anymore. And it's been like this for more than 10 years. And we had in the bug bounty a report that abused this legacy header, and an application fell victim to it because it still supported the except charset header. And the idea is to actually ignore this as an application, but as a web application firewall, we want to protect the application from that, and it's legacy anyway, browser not using it. It's likely to be an attack anyway. So let's check this out. Illegal header except charset. So I'm going to grab on the error log. Oops. I have to remove the space. Here we are. And then in the data field, we're getting the value that is actually around. So let's do mel data and then sum this up. What are we getting? So few ISO, this all doesn't look like attacks. So ISO 88591 is Western Europe, UTF-8 is nice. I think that is creation for UTF-8. That's okay. This is okay. So this all doesn't look like an attack. However, it's a lot and it causes false positive. So chances actually are that people are still using it, even if they shouldn't. I'm now taking the unique ID out of these requests and use that on the access log. Oh, sorry, I have to do this on the access log. So these are the requests. So let's check out the IP addresses. Yeah, it's fairly widespread. A lot of different users are using it. Our user agent sucks. And now this is interesting because you really have standard or seemingly standard user agent using this legacy header that I said is not longer active. I mean, here you have an AK aggregator, whatever that is, possibly RSS feed reader. Here is something special, whatever that is. Up here, oh no, that's Opera, that's nice. Oh, look, we have a Nokia device. That's fun. And then Mechanize, it's a Ruby script. But still, seemingly a lot of browsers doing this. So either they are using a legacy header in that browser, or somebody is pretending to be a certain browser, but it's actually fake. Maybe it's an attacker using a really existing browser user agent to do his attack. However, when I looked at this, it didn't look like an attack. So it's really a bit puzzling. And within CRS, we're now thinking about, because there's so many false positives by default, so in the default installation paranoia level 1, that we think about moving this rule that denies this to paranoia level 2, so people are not bugged so much. This happens, and at NEA, because I'm running bleeding edge CRS 4, so the development release, the latest rules. Good. Quickly back to the log report script. I think we're down here now. Here we have there's a bug in this script, because I have the GeoIP information. It should be printed, and then because URIs, this one is new, the asset manifest JSON. I don't even know what it really is. I'm getting 404s, and I should probably work on that a bit. And then the 500s, we've seen that, and then would be an example of a request. So what does this guy do? It was a Swiss IP address, and here we have an attack. Let's see. Here is that attack. Numeric host header, that's okay. Yes, that's not overly bad, but it seems he used a numeric host header in one of the requests. I don't know why. Seems it happens. Good. I'm blocking then consequently. Okay. Then I want to show you now the news of the false positive script. I've shown you this before. Going back to my browser, here is the same log file. I run the false positive analysis to check out from all the thousands of requests, so 34,000 alerts I got out of this. Are there any false positives? So this is this additional script that I'm developing and that we're licensing together with the CREGs. And here I'm running it against the log I've just shown you with an anomaly threshold of 3 and above. So basically everything will be reported. We have 430,000 requests. 30,000 requests qualify with an anomaly score above 3. 7,500 hit a relevant URI. And then most of this, very little to ignore. But then there are obvious attacks that I can identify in the access log. I remove those IP addresses performing those. And then the same thing for the error log. I've expanded these two filters a bit in the last few weeks. I've added more obvious attack patterns to that. And as you can see, this reduces it by more than 99%. And after these two filters, I mean, these are the most important two filters. I'm getting down to 14 requests for manual inspection, nothing suspicious. The ASN, a few countries on the deny list. I think I have Russia on the deny list, maybe Vietnam, if I'm not mistaken, all configurable. What I did here is an additional feature where I can turn the way around, because they give me only the potential false positives from Switzerland. Let's ignore all the rest, or give me only Western European countries or stuff like that, like my standard users. Netnea.com, that doesn't qualify because I have global users, but you get the idea. So this is a new feature here. Non-office hours is relatively interesting because, as you can see, 80% of the remaining ones are thrown away because of non-office hours. I don't expect false positive at 2 o'clock in the morning on the Netnea website, because if you're only browsing the website, there is no point with a false positive. And then rotating user agent doesn't apply. I'm ending up with 3 requests for manual review, 3 GET requests, 2 from Canada, 1 from Germany. I'm now clicking on the request, and this will take me into the CRegEx graphical user interface. Here we are. This is the first of these requests. The alert that belongs to the first of these requests. So what you're seeing here is the corresponding alert. And CRegEx responds with an advisory and says, hey, look, don't disable this rule. You should rather, update the allowed request content type variable. However, let me go back. This is a GET request. Why would a GET request have a content type? Only POST requests have content types. So this is whatever it is, but it's certainly not a valid request. And I'm not accepting text plain anyway, and certainly not on a GET request. So this is an attack or something stupid, a mistake, whatever. But I'm not whitelisting this or accepting this as a false positive. Next one, what is happening here? So we have this char set parameter, accept header with a char set parameter. However, this is also a brand new rule. I was puzzled before because we were talking about 926.10, but now it's 92600. It's a different rule than the one before. And in the accept header, you can do a char set parameter. Now, the funny thing is that the request here submitted true as value. Here, up here, you see the true. And this is also what CRegEx extracts. True is not a char set parameter, and it's also not a value that should be working in the accept header. So this is probably a mistake. I don't know what is happening. Somebody in Germany tried out something, but it's certainly not a false positive. I jump to the third one, and it's the same thing than we had before. Allow request content type on a GET request. Look, it's a GET request. We're not interested. That is not a false positive. Just for repetition, so you also see CRegEx in action. If this would be a false positive, I could then configure the rule exclusion here, probably by rule, for this URI. I mean, it doesn't make sense, but you get the idea how CRegEx would work. Could then do this by tag and say, hey, do this on attack protocol. All the attack protocol rules are removed for this URI. So that's in. So wrapping this up, CRS is still working on the bug bounty findings. Sorry, we're still not finished. Still no release date for CRS 4. It's imminent, but we don't have a date yet. We worked on the new findings and these JSON findings. My daughter is coming into the room. Yeah. And we consolidated the false positives analysis script, and this is going to be a full release very soon. So thank you very much for joining. This is it for this month, and I wish you good luck and stay tuned for the January edition. Thank you very much and goodbye.
Thank you. Bye-bye.
Thank you, Kristen. Goodbye.